Okay, so let's use these definitions, and I want everyone on your sheet to write down this example somewhere off to the side of these definitions. And I want you to get your book open to this section page. The page is on your notes. Get your book open, write this example down, and get your book open to this page. The first thing that I want to identify in this expression, I want you to tell me one term. Seth, you got a term? All right, so there's one term, 5a. Who can tell me another term? Jacob. 4b. Joe. Negative 3a. That negative is important. Graham. And 10. So we have a total of 4 terms. We have listed them all out. Make sure that you are identifying this in your notes. Make sure you are writing this down as an extra example. We have done this already. We should know how to do this. The next thing that I want to be able to do is I want to be able to identify our coefficients. And you have the definition of a coefficient on your sheet right in front of you. I just want to know what is one coefficient from this problem. Zach? No. Jacob? Just 5. So we just want to be really careful. A coefficient is only the number attached to a variable. So it has to be included with a variable, but when we talk about a coefficient, we talk only about the number. We don't include the variable anymore. So Zach, can you tell me another coefficient? Negative 3 would be another coefficient. Any others? Seth? 4 is another coefficient. Any others? Because those are the only variables. What do we call this 10? There's a special name, and I want you to look in your book. This was not part of your vocab words, but if you look at your book at the bottom of that page, what do we call that 10 that's all by itself, Alex? A constant. So we need to know that when we see a number and it is by itself with no variable, we call that a constant. So we have these coefficients that are attached to variables, and when we see just a number by itself, we call that the constant. The last thing that I want to identify here are the like terms. Do we have any numbers that are like terms? Jason, any like terms in this problem? Not quite. Seth, stop whispering behind your paper. Put your paper down. Put your paper down. 5a and what, Jason? Negative 3a. We want to be very specific. Because when I combine those like terms, I have to take 5a minus 3a. And I end up with positive 2a. So if I combine those like terms and simplify this expression, I get 2a plus 4b plus 10. And we just want to keep in mind, when we're writing in math, we want our variables to be in alphabetical order. A comes before b. And we always put our constant at the end. So your final answer, just make sure you have alphabetical order with the constant at the end of the expression. Any questions about these? Okay. The last thing I want to do, I'm going to write a pair of terms, and we are going to decide, are they like terms or are they not like terms? So the first pair I want to look at is 6x and negative 4x. Thumbs up if you think these are like terms, thumbs down if you do not. Okay, this one should be pretty simple. They both have x as their variable. These are like terms. We could combine them together. What about 3a squared and 1/2 a squared? Like terms, thumbs up, not thumbs down. Good. Again, we have this a squared. They are like terms. What about 4x squared y and 5xy squared. Thumbs up if they are, thumbs down if they are not. I will wait for everyone to participate. Okay, so they are not, because now we have different exponents with our variables. So just remember, the variables and their exponents have to be the exact same to have like terms. That doesn't really come into play a whole lot yet, but it will later on. So let's move on. We've got this example. Joe wrote it in the order I want, and I think that's fantastic. But before we do that, let's just talk about, where did you get this negative 7x from? Somebody else tell me. Where did he get the negative 7x from? Jacob? So we have negative 2x minus 5x, and that gave me that negative 7x. Combine those like terms together. Where did I get the 5y from? Where did that come from? Alex? 3y plus 2y gave me that 5y. What about that negative 11? Seth? 4 plus 7 gave me negative 11. What should it be, Joe? Should be positive 11. So our final expression is negative 7x plus 5y plus 11. And he wrote it this way. He was going to write it in a different order, but remember, when we write our final answer, and if you want to write it in a different order first, if you want to have 11 minus 7x plus 5y, write it that way first. And then just make sure that it's in that alphabetical order with the variables, constant at the very end. So I have to have negative 7x plus 5y, and the 11 should be positive as well. So you don't have to have it in the correct order in your first step. Just make sure by the time we finish the problem, we have it in that standard form for our expression. All right, so now we've got this example, and we've got this word problem, and we need to write an equation and then solve that equation for this problem. So, first of all, somebody tell me something important in this problem. Graham. All right, we need to know that Joe eats 5 egg rolls. Sorry, Joe, I didn't even type the problem, actually. Zach. Okay, Wanda eats 2 egg rolls. Graham. Javier. So Javier isn't very hungry. He only had 1 egg roll. Joe, I guess, was really hungry. That's okay. I'd probably be the one eating 5 egg rolls. Jacob, what else?
There's a $1 delivery charge.
We have a $1 delivery charge. So we pay for all our egg rolls, and we have a $1 delivery charge. Dante, what else? I should probably know what my total cost is. What else, Graham? So I'm trying to figure out how much does each egg roll cost. That's my ultimate goal. I spelled does wrong. Is that what you're going to tell me? Oh, okay. Okay, good. Yes, I did. I put OES. Okay, yes. So I need to know how much does each egg roll cost before the delivery charge is applied. I'm just trying to figure out what is the cost of each of these egg rolls. That's what I want to know. So we're going to write an equation. I need a variable. What is my variable going to represent in this problem? Jason? So we just want to make sure we're being very specific. We know that we're talking about egg rolls, and in this problem, I am trying to find the cost of each egg roll. Be specific. A lot of you got 1 point taken off of your quiz because you weren't specific when you named your variables. We weren't just talking about dogs and cats. We were talking about the weight of the dogs and cats. So in this problem, we are talking about the cost of 1 egg roll. That's what our variable represents. So now let's write an equation that we can solve to figure out how much each egg roll costs. Zach? Okay, I want to use the information that we have to write an equation. I don't think that I want to make sure we are writing down each part of information that we have. So it sounds like you're kind of getting to the solving part. I don't want to be there yet, because I think we make mistakes that way. So how can I represent this information that we have highlighted and write out an equation? First of all, I got to have an equal sign, and what is it going to be equal to?
7.
So it told me my total cost was 7. So my equation is probably going to be equal to 7, because that's my total cost. So now, what do I need to put together to get to a total of $7? Okay, so how am I going to represent, let's see, I've got 3 people. So I've got Joe, I've got Wanda, and I've got Javier. How am I going to represent Joe's cost? So, okay, so 5e.
Plus 2.
Is that my equation?
Don't get that dollar in.
Because here's how much Joe's egg rolls cost. Here's how much Wanda's egg rolls cost. Here's how much Javier's egg rolls cost. Plus, we had to pay $1 for delivery. And that total has to equal $7. My actual final total that I paid for everything. Are there questions about how we set this equation up before we move on to solving it? Because you may get a problem on a quiz, on a test, on your homework, and you may look at it and you may be able to come up with the answer fairly easily. Some of these problem-solving problems, we can just come up with the answer just by guess and check or whatever different method we use. But what we are talking about is we are trying to figure out how to write equations. So if you can't write the equation, you will not get full credit for the problem. A lot of these problems are worth up to 8 points. If you can give me an answer, well, good job, you get 1 of those 8 points. I'm trying to figure out, we got to be able to write and solve an equation, not just come up with an answer out of thin air. So are there questions about the equation part? All right, then let's go ahead and solve it and try to find our answer. How am I going to start solving this equation? Jacob? All right, so when I combine like terms, what do I get? So 5 plus 2 plus 1 gives me 8. I still have that $1 delivery charge, and my total is still 7. This should look very familiar. We have seen equations like this. We have worked with them all last week. We worked with 1- and 2-step equations. Zach, what's my first step? What's my next step here?
Check both sides.
Good. Got to do it to both sides. So I got to get rid of this 1. Now I have 8e equals 6. Now what, Dante? Good. Now I divide both sides by 8. 1 times e is e. Now let's think about what e represents. How do I want to see your answer? Zach? So in decimal form. I don't really want your answer in fraction form for this problem because we're talking about money. So what is the price of 1 egg roll? Alex?
Whatever.
Doesn't matter. So we want to make sure we label our answer. We're talking about cost. We're talking about money. And when I take 6 divided by 8, I get 7.75, or 3/4. So my final answer is 75 cents. Name your variable, write your equation, solve your equation to answer the question. Questions about any of this problem? All right. Then let's move on. We talked about combining like terms. Now we want to talk about the distributive property. Now, we also should know, in multiplication and addition, does order matter?
Oh, no.
Not in multiplication and addition. Multiplication and addition are commutative. So it doesn't matter what order I do them in. So this is the same as AB plus AC, because I can just flip the order that I multiply. This is also the same as A times B plus C. I can move this A to the front and do my multiplication in any order. So no matter where we see that variable or that number, whether it's before or after the parentheses, does not change the problem. I still just have to multiply whatever's outside by everything that is inside parentheses. So let's look at this problem, example 1 on this page. I think we've got all the right steps. Let's just make sure we have it look nice and neat so we know exactly what's being done. So let's just do one thing at a time. What was the first thing that Graham did? Graham had to distribute. So we see these parentheses and we distribute this 3, so we get 3b plus 15 equals 12. Again, now we have a problem that looks exactly like what we were doing all last week. So all we're doing is we're adding a set. We're either combining like terms or we're using our distributive property. We'll put all of that together. So we're just adding more steps to our equations, but we're still doing the same process. So I multiply that out. Then he subtracted 15 from both sides. So now we have that 3b equals negative 3. And then he divided both sides by what value? Because I think your answer is right as negative 1, but negative 3 divided by negative 3 is positive 1. So what do I want to divide both sides by, Joe? Positive 3. So we did everything very, very close. We got the right answer. We just want to make sure we want to divide both sides by 3, and b equals negative 1. How can I check my answer? I can substitute it back into my problem. So I can show that 3 times negative 1 plus 5, and I can check and see if that equals 12. What do I do first? Do I have to distribute?
No, you do print.
Okay, what's inside my parentheses? Negative 1 plus 5. Now, when I have a variable, I can't combine b plus 5, so I have to distribute. Here, I can combine negative 1 and 5, and I can get 4 is 3 times 4, 12. Yeah, so my answer is right. It checks out. It is correct. I have found the right answer. That's up to you. You're going to miss a lot less points if you check your answer and you know whether you're right or wrong. Yes, Graham. You just wrote down a negative instead. And that's all right. If you write down that work, I can probably look and see, hey, you have everything else right. You probably just accidentally wrote down a negative sign. Questions about that one? Okay, so now let's use this to write a word problem. First of all, I've got a lot of words here. Let's find something that's important. Zach? Okay, I need to know that I have a total of 5 coins. Seth?
You only have dimes and nickels.
Okay, I only have dimes and nickels. Joe?
You only have 35.
Okay, I have exactly 35 total cents. Graham? My question is asking me how many coins are dimes. Anything else that I need to know? Seth? Do I need to know that to write my equation? It's not going to have anything to do with the equation that I write?
We need to know it.
Okay, do I need to know that I'm approaching a toll booth to write my equation? No, I don't need to know that. We don't need to know that we're approaching a toll booth to know how to write the equation. I would suggest highlighting, circling, underlining, making a list right next to. You need to know what's important. Because if we can narrow it down, now I only have a handful of words that I'm looking at instead of a full paragraph problem. So now I need to name my variable. What is my variable going to represent? Zach? Okay, so I'm talking about D, and am I talking about the value of dimes, the color of dimes? Okay, so I'm looking for my variable D represents the number of dimes that I have in my car. We also said in this problem that we've got nickels. We've got dimes and we've got nickels. So the other thing that I need to do is I need to find some way to represent the number of nickels that I have. Let's say, not thinking about our variables right now, let's pretend like I have 1 dime. How many nickels do I have? If I have 1 dime, how many nickels would I have? Somebody give me an answer and a reason. Joe, you're saying 4. Why are you saying 4?
Because we have 1 dime and we have to go with 5 minus 1.
Okay, I want to use this reasoning for right now. Because the 35 cents is going to come into play later, but if we know that we have 5 coins, and one of them is a dime, Joe says that 5 minus 1 tells me I have 4 nickels. So 1 dime, 5 minus 1 gives me 4 nickels. Now let's say I have D dimes. How would I figure out how many nickels I have if I have D dimes? I want to know, how do I represent the number of nickels if I have D dimes? Nope, I can't have 2 variables. I don't know how to solve equations with 2 variables. Okay, but I don't know that D is 1. I know that I have D dimes. We said when I had 1 dime, 5 minus 1 gave me 4. Greg? Okay, do I know right now that I have 2 dimes? No, I don't know that. I know that I have D dimes. So how do I figure out how many nickels I have? But I can't just substitute. I don't have an equation to substitute numbers into yet. We just chose an example of 1, and we said we took 5 minus 1 to tell me how many nickels I had. So now I don't have 1 dime, I have D dimes. How do I represent how many nickels I have? Greg? Okay, I have to use that 5. What do I do with the 5? What? Okay, so are you telling me how much a nickel is worth? That's going to come into play later, but that's not going to tell me how many nickels I have. But I do need to know that. I do need to know that a nickel is worth 5 cents. I'm going to need to know that for later. Zach? Okay, again, I only want 1 variable. Having more than 1 variable, we can't solve this problem. We'll be able to later, but we can't right now. So again, when we chose to say that we had 1 dime, we took 5 minus 1 to tell me how many nickels I have. Now I don't have 1 dime, I have D dimes. How do I figure out how many nickels I have? This is what we have said so far. If I have D dimes, how do I figure out how many nickels I have? Jacob? We don't know that I have 2 nickels. I have no idea at this point how many nickels I have. I have to write something to figure out if I have D dimes, How many nickels do I have? It doesn't matter right now how much they're worth. Jason, do you have an idea? Or is your arm just propped up on your desk? Okay, if I add dimes and nickels, if I take the number of dimes plus the number of nickels, what does that have to be? Nope. Okay. So if I add dimes and nickels together, it has to be 35. So now, if I want to know how many nickels I have, what do I have to do to figure out how many nickels I have? What do I have to do to this equation? Subtract what? So if I subtract D from both sides of this equation, I get that N equals 5 minus D. So if I want to know, if I want to represent the number of nickels, how do I represent the number of nickels in this problem, given D dimes? It's on the board. I mean, we just did it. So if I have D dimes, how many nickels do I have? 5 minus D. Because I know if I add the two values together, I have to have 5 total coins. So if I know that I have 5 total coins and I have D dimes, I can take that number away from it, and that's going to tell me how many nickels I have. Do we see where that came from, or are we still confused? And we will eventually get into where we write 2 equations and we have 2 variables, and then we can use this as one of our equations. But right now, I can't have 2 variables. I don't know how to solve using 2 variables. So I have to only have 1. So I can represent dimes with D, which means I have to have 5 minus D nickels. So now let's think about, we also said that the amount of money that they're worth is going to come into play. So we know that nickels are each worth 5 cents and dimes are each worth 10 cents. So now we need to write our equation. So what is it going to be equal to when I write this equation? I know I need to have 35 total cents. So this is the total money. I know that I've got some money from dimes. And I know that I've got to have some money from nickels. How am I going to represent the money that I have in dimes? If we have 5 dimes, how much money do you have? Okay, where'd you get that number from, Joe? Okay, we took 10 times 5 and got 50 cents. So if I have D dimes, how much money do I have in dimes, Zach? What do I have to do with the 10 and the D? I have to multiply them. So Jacob, how do I represent number of dimes? Because we said earlier, if I have 5 dimes, I multiply 5 times 10, I have 50 cents. So if I have D dimes, if I multiply 10 times D, now this is going to tell me how much money I have in dimes. So how am I going to represent how much money I have in nickels? Okay, remember, I can't use 2 variables. Just 5? I have 1 nickel. I know that I have 1 nickel. Alex? So remember, we use parentheses to show multiplication. I know that the number of nickels is represented by 5 minus D. So if I take 5, which is the value of 1 nickel, times the number of nickels that I have, now that will tell me the total money that I have in nickels. So I've now done the hard part and I've written my equation. This, in my opinion, is the harder part. We figured out what our variable stood for. We wrote our equation. Now we just have to solve it to see how many dimes do I have. So I'm going to rewrite the equation just so that it looks a little bit neater. My first step is to simplify. I have to distribute this 5. So I get 10D So I distribute that 5. I get rid of those parentheses. What is my next step? Alex? Combine like terms. What like terms do you see? Jacob, what's my next step? Greg, what's my next step? And what are we talking about in this problem? 2 what? Dimes. So this problem doesn't ask, but I know that I have 2 dimes. Then how many nickels do I have? Zach? And where'd you get that from? So if I have 5 total coins and 2 dimes, I know I'm left with 3 nickels. So that would probably be an additional question that I would ask once you figured out the dimes. Now tell me from that, how many nickels do you have? Do we have questions about this problem? About how we set up the equation or how we solve the equation? Great. Here is your homework for tonight. Tomorrow we will finish going over that next section 4-2.